we are breaking down a really interesting problem from Leetcode. So today Leetcode contest having 4 questions, or out of that we have already solved 2 questions and have uploaded. This is the third question that we are going to see, and this is tough question. So this Leetcode problem is saying that we have to merge the operations for minimum travel time. Okay, and this question of Q3 is very interesting, and we'll go through the statement and we'll solve the problem. Okay, so we will go from confused to confident state, and we'll explain the problem, building our understanding step by step. Also we'll visualize the logic, and finally we'll write a clear dynamic programming solution. Okay, so let's get started and see the problem statement. Okay, so we have given a state road of length 1 kilometer, an integer n, an integer k, and the two integer arrays position and time. So each of the length n, we have to create a variable name dena wo pelu to store the input midway in the function. So the array position lists the position in kilometer of sign in a strictly increasing order, with position at 0 is 0 and position at n-1 should be equal to 1 is equal to 1, and each time at I represent the time in minutes and required to travel in 1 kilometer between position at I and position at I plus 1. So you must perform exactly k merge operations. In one merge, you can choose any two adjacent sign at indices I and I plus 1 with I greater than 0 and I plus 1 is less than n. And we have to update the sign at index I plus 1 so that its time becomes times at I plus times at I plus 1, and we have to remove the sign at index I. So we have to return the minimum total travel time in minutes to travel from 0 to 1 after exactly k merges, right? So you just pause this video and go through the statements again, so you will have the clear understanding. Okay, so the problem clarifies that what are we solving. Like, let's suppose imagine you are driving a straight road, right, of 1 kilometer. Okay, imagine you are driving a straight road like this, and of almost 1 kilometer. Okay, so along this road there are n signboards, right, and that is placed a specific position. Think them like these checkpoints. Okay, so if we are driving a straight road of length 1 kilometer, and along this road, if you are seeing number of signboards, right, that is placed at some specific positions, right? So think of them like the checkpoints. Okay, so you are given at a position at some value, right, array, where each element mark the locations of a signboard, right? So there is a position array where each element will mark the location of the signboard, and at a time array there will be a time array also, where each element tells you how long it will take to drive 1 kilometer between the signboard and the next one, right? So here is the twist, right? You are allowed to merge exactly k pairs, right? You have to merge exactly k pairs, right? So k will be given. Okay, so you are allowed to merge exactly k pairs of the adjacent signboard. So when you do that, the time between the two merge sign becomes time at I plus time at I plus 1. Simply, right? If you want to merge it, just merge the time at I plus time at I plus 1, right? And you will merge the two signs, and it will become it become the single time, right? Means you are merging the time between the two merge sign. It become what? Time at I plus time I plus 1, right? And you remove the sign at index I, right? So you will update the time at I plus 1, right? You understand, right? So you pause this video, right, and you go through this example, the example 1 that we have given. Okay, so now you can think of what is your job, right? So after exactly k merges, right, we have to calculate the minimum total travel time from position 0 to L, that or 1 we have given, right? So let's suppose we have given L is 10, N is 4, K is 1, and the position array we have given and the time array we have given, right? So we'll talk much more about this, why the output is coming 62. You can go through the explanation that is saying that, right? And we'll understand how it is working, because we will talk too much about this example to understand actually how to do that, because this is hard problem and you have to understand the problem first before going through everything, right? You understand, right? So let's suppose we have given this example, right? What we have given this example, so L we have 10, n equal to 4 and k equal to 1. So this is we have given. So what we have to do, right? So if think that this array look like this one, so the array position we have given is position, right? So this array is called position and this array is called what? Time. So what we have to do, right? What we have to do, just think what we have to do, right? So let's suppose if this is we have given, right? So you are allowed to merge what? Once, only one time, as k is given 1, right? So let's say you merge at index 1, okay, and you will remove the position at 1 that we have given here, and you will update the time at 2, let's suppose, okay. So how we are going to do that we will see here, okay. So what you are allowed to do, you are allowed to merge at a only one time, right? And where we will merge, you will merge you want to merge at this position, let's suppose. So remove position at 1 equal to 3, we will remove this one and will update this position. How? This 8 plus 3 will become what? Because this time will take, right? If we are removing here, means now the next point will go 0, 8, 10, but this time will get added where? Here. And so we have to update the time at 2 at this position. This 8 plus 3 is 11, right? So now it will look like how? Like this. We have 0, 8 and 10, right? And now this time 3 plus 8 is 11 get updated here, right? So total segment if we'll talk about, right, it will come what? 0 to 8. First of all, it will come 0 to 8, right? So 0 to 8 is a 8 kilometer, right? 0 to 8 is 8 kilometer. This is called position. So from 0 to 8 is 8 kilometer, right? And what is the time we have? 5. So we'll multiply 8 into 5, right? 8 kilometer into 5 is 40. So total travel time will become what? 40, as you can see here. So from 0 to 8, it will become 8 kilometer into 5 is 40, right? From 0 to 8. Next, we have 8 to 10, right? Means from 8 to 10 is what? 2 kilometer. So 2 kilometer into 11, what will become? 22. So total will become what? 40 plus 22 is 62, right? And that's the minimum possible travel time, right? For this case, because we have given the merge is k, right? Merge k is 1, right? So only one we have to merge it, okay. So that's the minimum possible travel time, and you have the answer 62. So you understand this statement, right? Let's understand the example again. What you have to understand the example again? So the example that we have given, 0, 3, 8 and 10 position array and 5 to 6 in time array, right? So if you draw in a table, so these are the segments. So from 0 to 3, because see we have 0, 3, 8, 10, these are position and these are time. So what I have done, you see the segment, if you distribute the segment, right, the position array was 0 to 3, then 8, then 10. So we will take 0 to 3 is one segment and the length is 3 kilometer. 3 to 8 is 5 kilometer, 8 to 10 is 2 kilometer, and these are the times that we have given, right? So we have already updated the time, right? So it was what? It was, yeah, it was 8, right? So 8 plus 3 will become 11, but for now it is 8 only here, right? So now after the updation, time is like this, right? So 3 into 5 is 15, 5 into 8 is 40, 2 into 3 is 6. So total time is 61. So total time no merges. So if we do not do merge any merge, you will get the time 61. But we must perform one merge. if we will not perform any merge, then that is not good, right? We have to perform at least one merge because the question is saying that. So you have to merge at least one time. Total merge we have to do, right? And that we have to remove the sign from there. Okay. So what is the options here? We want to keep only n minus k position, right? So what n is given, right? So if n is given, some value will be there, right? Some n, as you can see here, you can see n is given 4, right? And k is given 1. So n minus k is the thing that we required. So n minus 3 is, and 4 minus 1 is 3. And so only n minus k position we required. So exactly 2 segments we need. So what we will do, we'll merge 3 to 8 and 8 to 10. So this part, like 3 8 and 8 10, we will, these 2 segments will merge it, right? So after the merge, it will look like how? 0 to 3 and 3 to 10, right? Because 3 to 8 we have done that, we have merged it, right? And so now it's 3 kilometer, it's 7 kilometer, let's suppose. Okay. And time is also got merged, right? So we'll do 5 and 11. This is 5 and this is 11. So total segment is what? 3 into 15 is 15, 5 into 11 77. You will do the plus, you will get 15 plus 77, and that is got 92. So now you have understand, right? So there was 2 options to merge that. Either you merge the first 2 or the last 2. If you merge the first, if we have merged first one, then we'll get the minimum one, but we are getting here now too high, right? And so the question was, the option 2 is better. Why? Because of option 2, 0 to 3 and 3 to 8, if you'll merge, we'll get what? This value will get, right? And so we are getting what? 61, that we have already seen, right? So this example we have already seen, just I am showing you again. So 0 to 3, 3 to A, right? And if you recalculate this, because we have already merged, right? And after the merge, you will get what? 61. So the thing is, this is the best option, right? So now you understand the minimum. What is minimum? What is maximum, right? So 2 merges were there, and that we have already seen, right? And if you talk about this one, so this option is better to merge it, right? Because that was a too much. Now think, the original was given as a 0 kilometer. After going for the 5 kilometer, after that so it will take 5 minutes, and then you will reach to 3 kilometer, then 8, like this we have given. After the merge is 0 5 8 11 10 will be there, right? Means the first segment is 0 to 8, right? As you can see, 0 to 8, right? And then other segment is 8 to 10, right? So if you calculate all the time, you will get 62. That will be minimum travel time, and you have to return that. So you are given what you have given, the road segment defined by positions we have given, and their corresponding time per kilometer we have given. So you must do exactly k merges of adjacent segment to reduce the total travel time, and each merge will combine and remove a sign, right? So after the merge, you have to remove that sign and you have to combine it, right? That we have already seen. And our goal is to minimize the total travel time from 0 to 1, right? That we have given. So DP we will use here. So we'll go through the high level idea. So we'll create a DP array that will be 3D, and DP at step will take current index and the last index. So we will choose best cost from the current position using the current segment rate, and we'll start from the step 1 at the position 0. So you can try jumping from jump to 3 8 and 10, so on, and each jump creates a new segment with its own rate. That is called prefix sum, that we will see, and you recursively move forward and will keep picking best total combination with exactly n minus k segments that we had given, and we have seen that. So the approach that we are going to use here is dynamic programming. So after performing exactly k merges, we have to minimize the total travel time, and that we can define, like if we'll define like some or some over all segments, right? That we can see the distance between the sign and the time per kilometer of that segment, right? That will be the sum. So we have to multiply that, and we have to make the sum. So all segment will do sum up, and then we will return as a minimum total time travel If it is minimized, then we'll return that. Let's understand some steps to do in the dynamic programming. So first step we will do, understand the structure. So we will define the road into steps in minus k segment, because k is given, n is given, right? So we'll, from the given n minus k segments, we'll get the steps. So we'll define decision points where each segment start. For each segment, we will calculate total cost. Total cost will calculate how? Position at next minus position at current, and will multiply with the time rate, where time rate is sum of all the time at I values between current and next. In the dp state, we'll take dp at k, I, and last. So this will be the minimum cost to divide the road into some positions, right, or some segment, you can say. That will use to calculate the rate. Okay, and then there will be some state like k, I, and last. You can pause and you can understand these steps. Okay, so in the third step, we will process the prefix sum. And to do the prefix sum, you can calculate prefix sum at I is equal to time at 0 plus so on till the I, right? And you will calculate the prefix sum of the time array. So the cost per kilometer between the last to I is prefix at I will do minus, and if last is greater than 0, we'll do a prefix last minus 1, otherwise put 0. Then we'll go for the recursive transition memorize state, where we'll solve this method. So we'll create the method, we'll pass k, I, and last. So for next, we'll take I plus 1 to n. We'll find the distance, position at next minus position at I. You will get the distance, you will get the rate, the prefix at I minus the last is greater than 0, then we'll take the prefix last minus 1 or 0. We'll put the rate. Now you have to multiply the distance and rate, and you have to plus. You can do the recursive call to, you can use k plus 1 and I plus 1, and next will be remain the same, right? Because we are moving on the next. Then the base case will take, if k is equal to steps, will return 0. If I is equal to n minus 1, else it will move to infinite. So the final step will take a memorization. We'll use 3D DP, and we'll take 3D DP long new steps. Will take steps plus 1 and n plus 1, and will finally will return the result in DP at I, k, I, and last to where the recomputation. Okay, so use to store. Why we will take the store? For the avoiding the recomputation, will not calculate again. So to write the DP, right, just pause this video and go through. To first of all, you have to do compute prefix sum of the time, then define the total steps as n minus k, create a 3D DP array for the memorization, write the recursive function to solve k, I, and last. You can try every next segment boundaries, calculate a cost for the segment, and recursively find minimum total cost, and then finally return the solve at 100 as a result. You pause this video, try by yourself, and then move ahead for the implementation to understand. So first of all, that method we have given is pre-compute prefix sum of the travel time to quickly get rate over a segment. So the method is given is mean travel time. This is the main method we have to invoke in the Leetcode, and then we have given road length, total sign, merges, and positions and times. So first of all, we'll create the stores that we have given. So we'll create the store, right, where we'll store the input and compute data. So store at 0 is position equal to positions will pass. Store at I will 1 will take times. So now we'll calculate the prefix. So to after the prefix, you have to assign times at 0 at a prefix at 0, and then for all the prefixes to calculate from I equal to 1 to will go to the total sign minus 1, and we'll calculate the prefix sum at I minus 1 plus times at I. You will keep updating you will have all the updated and calculated value at the prefix sum array. And last segment is not used directly, so prefix sum will take a total sign minus 1 and will provide equal to prefix sum total sign minus 2. Now we'll create a mean travel. Some steps will add into this same method, right? So step 1, that we have to do what? We have to calculate the prefix sum of the travel time, and then we have to store all the values, right? After that, we have to go for that step 2, where we'll compute the number of segment after the merges. So we'll take required steps. Required steps we'll get from the total sign minus merges that we have given, and then we'll calculate the memorization cache for the DP, where DP at DP will define like required steps plus 1, total sign and total sign plus 1, and then we'll return int, will do compute mean time, and this method will provide at 1 0 0 and require step position and prefix sum at DP. So we'll write the one method, helper method, compute mean time, and so for that we'll create we'll pass the parameters, as you can pause and see. So the compute mean time is a helper method where we'll pass steps, current index, last index, total steps, positions, prefix sums, and DP, right? And so this recursive function will keep calling the steps, and you will calculate. Like, first of all, you have to define the base case. If already computed, you will return it like DP at steps, current index at last. Otherwise, you will find first rate, then you will calculate the steps equal to this, then return the DP at step, and you have to update this value, right? Otherwise, you find the minimum total cost, and then try to extend all the next possible signs, right? So you calculate the distance, cost from the next, and then check the, if cost is less than the long value, find the total cost, and you get the minimum total time. So each time the total cost will get updated, and so we'll get the minimum cost also will updated. And finally, we'll return DP at the step, current index, last index, and we'll provide the mean cost. And finally, we are returning this index, right? So that's all for today. And to understand the complexity, time complexity is O of NQ, and the space complexity of N square, ONQ, sorry. And so why the ONQ is there, right? So DP state is defined in 3 parameter, right? First of all, the DP at k, I, and last having the 3 parameters. So the k ranges from 1 to steps n minus k. So it will take O of n. I will take from 0 to n, that is n square, and recurrence steps is also there, that may loop like from next will take I plus 1 to n, and it will take O of n time per state, right? So overall state is O of NQ, and so the work per state is O of 1 to O of n, and the worst case is will become O of n4, right? So but there is a constant is given, like n should be less than equal to 15, k should be less than 10, and so the memorization each step of DP is computed only once, and so it works efficiently in the practice, and so it will become effectively O of NQ. So why the space complexity of NQ? So there is a DP, right, and it is taking of NQ because the prefix sum we are calculating, and the call stack we have in the recursive order, and that is why the ONQ is coming. So thank you guys, thank you for watching this video. If you have done any doubt, please ping me in the comment box and let me know. If you have anything in this video, I have tried a lot to implement the this solution, and I tried to cover everything that you want, and please go through this code, right? Better you create a notes, right? Take a white page, write these solutions and try to understand. Otherwise, read again and go through the video again, so you will understand easily. First of all, go through overall and try to read it again, and better you create a notes, because sometimes it will help you. Okay, thank you guys, thank you for watching this video, and thank you for your time.